Howdy, folks. My name is Arul Verma, and for this week in CS 128 Honors, we're going to be going over data types and functions. So our goals for today are to talk about the compound data types. Last time we did the scalar data types. Then we'll go over functions, how to create them, and then vectors and arrays. So let's start by talking about what data types are. We talked about this previously, but just as a recap, data types are the method by which we tell the compiler what type of data it's going to be looking at. These are built in so that users can actually use keywords in order to specify to the compiler what exactly the compiler is going to be looking at. There are two primary types of data types, scalar and compound data types. Last week we covered all the scalar data types, that is integers, floating points, booleans, and characters. So this week we're going to be talking about the compound data types, tuples and arrays. Now before we start there, you'll notice that there's one compound data type that's missing from this list, and that is strings. The reason we don't cover strings in this lecture is because strings have a slightly more semantic-based understanding compared to tuples and arrays. And that's because strings also have subsections like string slices or string literals, and these all behave differently according to the Rust compiler. However, your first MP and homework will both be very involved using strings. So we will be releasing a supplementary lecture tomorrow that'll cover more details on how strings work, how string slices work, and many of the key functions that'll help you get through that homework. Of course, if you have any other questions, make sure to come to us over Discord so we can help you. But strings are a lot more complex for this lecture, so we'll just be going over tuples and arrays before we move on. But make sure to watch the lecture tomorrow for more details on strings. So let's start by talking about tuples. So the one key difference between tuples and something like a vector is that tuples are of fixed length. They can store different values of different types. So you can store, for example, you see this here. We have let x be an I32, F64, and a UA. So we have an integer, a float, and an unsigned integer. And we can see that this is totally fine. Our compiler can store these three different types into one tuple. And it's you don't need to declare them, of course. We can do implicit declarations, and that's totally fine. So we can see we have let tup here be 500, 6.4, and 1. However, it's worth noting that if you do this, that this won't be an unsigned, this will be an integer. So and many of the rules we talked about previously where default sizes will be applied. So you can implicitly declare, but of course, be aware of what that does. Tuples are inherently immutable. You cannot use the mute keyword on tuples, and tuples cannot be changed. So once you declare a tuple, that tuple exists forever. If you want to access any value from your tuple, you can zero index. So you can use .0, .1, and .2. Because it uses dot notation for access instead of like arrays, which use square brackets. So if you wanted to access a particular element, you use the dot, or you can do the let parentheses xyz equal to, and that also works totally fine. Empty tuples are called units because they have no values inside. This is the default return value for functions. So you can see that if we just had this function main here, its default return type is actually a unit, which is just an empty parentheses, and its value and its type are both just considered a tuple. Next, let's talk about arrays. Arrays, unlike some other languages, have fixed length in Rust. So they're a lot like C++ in the sense that you use square brackets to declare them. They have fixed length. You cannot do memory assignment like you can in like C++ to get around this, or you can't do like I know Python has infinite length lists. That's not acceptable here either. You must store the same type value. So unlike tuple, you have to store the exact same type. Of course, implicit declarations are allowed. You can do let a equal 1, 2, 3, 4, 5. This is totally acceptable. But of course, this will not be mutable because we did not use the mute keyword. But they can be mutable. You can say let mute a equals 1, 2, 3, 4, 5. And that's also acceptable. You zero index all of your arrays. You access element using the square bracket indexing. So before with tuples, we use dot indexing. Now we use the square bracket. So we can see let first equal a0. This would give us 1. And let second equal a1. This would give us 2. You can also declare your length of your array inside your declaration. So you can do let a colon I32, which is our type, a semicolon, and then the number of elements inside of our array. This is an acceptable declaration. So this would be how you declare the size of your array along with the type. And the last thing is to know that if you use an invalid index in your array, you'll throw a trace error. So do be careful when you're iterating through your arrays, because if you go out of bounds, you will have an error. Finally, let's talk about functions. Functions are slightly more interesting in Rust. The convention in Rust for functions is all lowercase letters with underscore separating words for the name, and you want as descriptive names as possible without being too verbose. This is what we call snake case as opposed to the camel case that you'd see in other languages. I know Java has camel case as its standard. Here we prefer Python's snake case. So we can see we have like print labeled measurements here, and you can see that's an example of where we use underscores. The keyword fn is what you use in order to declare your function. And the important thing to realize is that when you're using query learn, you also have to use the pub, the pub keyword prior to this. So it would be pub fn main. And this can trip people up because of how query learn is slightly different from the core language. We are still fundamentally working in Rust. The only thing is that pub is a crate keyword, and we'll go into more details for that later. Now, the order of declaration of your functions does not matter. In some languages, it does, and it's important to declare the language before you use it. But you can see here, I've declared print labeled measurements after I use it in main. And this is not an issue in Rust because of how Rust deals with code. We talked about this briefly in the discussion section yesterday, if you guys were able to attend on Monday. But if you weren't, basically Rust catches all of its errors at compile time rather than at runtime, and it's very rare to get runtime errors. More likely you'll have incorrect behavior at runtime, but that's more a function of having incorrect code. But it's very rare to run code and then have it break. And the reason for that is how Rust deals with memory. What it does is it goes through all of your code and it stores it all inside memory prior to it actually being ran. So during compile time, the compiler stores all of these functions in main memory so that it's very easy for the code to access when the code is being run. And this is especially true for functions and is the reason why you can declare functions out of order. Because your compiler is going to go through memory and it's going to say, oh, I have this function called print labeled measurement. I'm going to just create an instance in memory where this print labeled measurement tag will reference. And then it'll go through all of the lines of code and it'll put instruction code inside your memory for right after that print labeled measurement pointer has been assigned. And I know this is like a lot more detailed than you may be fully clear, but all you really have to understand is this print labeled measurement gets an assigned area in memory, and then all of the code inside gets assigned memory right below that declaration, that right below that original address. And that's done for all of your functions. So that whenever this print labeled measurement is called in main, all it does is it says, oh, I know where this is in memory because it's already been loaded. And it just goes to that place in memory and reads the data. So this allows you to essentially declare out of order, and it's very versatile in its use, and is one of the key things in Rust that helps make coding more smooth. So as I said, the keyword fn indicates a function declaration. For your function body, you want to use curly braces. So you can see we've always used curly braces to denote our function body. The general standard is you also want to have parentheses before that. Not you want to, you have to have parentheses before this. And this declares your parameter for your function. And that's basically the input you're giving to the function. So if you don't want to have any parameters, you can have an empty parameter, which is your empty tuple, like we talked about earlier. But if you do want to have parameters, you have to declare their type. You can see an example of this in my print label measurement right here. We have our variable value, which we're passing as a parameter. We must declare the type of it. And we can have a second parameter as well, and we must declare the type of it. You'll notice that they both have different types. Value is an I32 and unit label is a character. And that is the point. You can have any type of parameters, but you must declare what that type is so the compiler knows. Parameters do not necessarily have to have the same default type, as I said, and they are passed default by value and are immutable. Meaning, if you try and edit them, like you can pass mutable parameters. Let me make this clear. You can pass mutable parameters, but without using memory management, which we aren't going into just this lecture, those values will not be reflected outside the function. So if I was to make this a value colon mute I32, even if I was to change value somehow inside this function, that value's change would not be reflected in my main. So it's important to know that you are passing by value, and that just means that I'm just passing whatever the value is of my data. I'm not passing the location in memory where that data is stored. And this is something I'll cover in far more depth when we talk about borrowing and ownership, but it's just important to understand that whatever changes I make inside my function are not reflected outside the function. So As we talked about earlier, mute is something that you have to pass into your function. I briefly talked about this. And I also mentioned borrowing and ownership and the way to change data inside your function. And that's using the ampersand symbol and the star. They're all part of parameter types and they have to be passed as for proper assessment of values if you want to do things with your parameter. Don't worry about what the ampersand and star do currently, but if you want a brief explanation, I'll just give you a really quick one. If you don't, you can just skip forward around a minute or half a minute or so, and you don't have to worry about it because it's not important right now. Essentially, what the ampersand does is it allows you to pass the location in memory instead of the exact data itself. So when we say pass by value, what we mean is you take the number, you take the value. So if I had a variable called 5 and I stored 5 in it, then that value, that variable 5, or okay, that's actually a very poor example. Let me rename my variables. Let me say I have a variable x and in it I stored 5, just like this code here. So let x equal 5. So if I was to look at that x is actually an or address in memory where data is stored. And at that address, the number 5 is being stored. So if I use the ampersand, I'm saying just look at the address. And that's what we mean by pass by reference. Because when you say look at the address, that address contains the data, the original data. So if we pass something with the ampersand, if we pass the variable using that ampersand, we tell the function that change what's in this address. If we don't use ampersand or star, then what's happening is the compiler says, okay, you probably don't want to change the original value. So we're going to just take whatever data is inside the address where X is stored, and we'll put it in a separate address location and pass that to our function. So that's what we mean by pass by value. So that was, I know, a lot more complex than it needed to be, but and it's not very important for relevant homeworks or MPs, so we'll keep moving on. Now, if you want your functions to return a value after you call them, you use the arrow symbol, which is literally a dash and a less than sign. And this is how you'd return a value from your function. So we can see we have fn5, arrow i32. And this just means that our function 5 is going to be returning an i32, and that value it returns is 5. You can notice that we don't have a keyword for our return. And that's because if you want to return, there's no return keyword. All you have to do is just put the value you're returning without any parentheses at the end, or sorry, any semicolon at the end, and that value will automatically be considered the return variable and it will be returned, as long as it matches with the return type. You can only specify a single type to return. You cannot return multiple types. So if you want to return multiple values from a function, you have to use something like a tuple and array. Finally, let's talk about vectors. Vectors are not a data type the compiler explicitly realizes. They're not built into Rust. And implicit declarations of vectors will cause errors in your code because vectors don't have an implicit declaration handler. Vectors can only store a single type of value, be that i32, a float, unsigned integer, character, whatever. And so you have to declare the type that you're going to be storing, and they can have a variable length and they are mutable. So vectors are your equivalent of lists in Python, but they can only take a single type. Vectors are implicitly mutable. You don't have to use the mute keyword as far as I'm aware, although I would test that. And vectors can be declared with the keywords vec : new, which is the function that's built into the vector library. Or you can use the vec square bracket macro, which is a macro made by programmers who have worked on top of Rust. However, these two declarations are not interchangeable. A vec i32 and a vec with the macro are not the same thing, fundamentally. And there is a transition function in order to transform a vec macro into a vector. So be aware of which one you're using. And if you want to use one or the other, make sure you know the transformation functions to switch from the macro to the main or the main to the macro. These are able to be found on the textbook, and I highly recommend looking at the textbook for more details on how vectors versus macros work. If you want to access elements inside your vector, you use the square bracket indexing with starting at 0. So this value of 1 would be stored at vec square bracket 0 or v square bracket 0. This would be v square bracket 1 and v square bracket 2. So yeah, use square bracket notation starting at 0. Now, if you want to add elements to your vector, you use the dot push function. So you can see we have an example here. We have our let mute v equal vec mute. So yeah, okay, I was wrong. Vectors are not implicitly mutable. You have to use mute keyword. That's my bad. Make sure you're aware that you use the mute keyword. It's just good practice in general. If you want to have something that you want to edit, that you use the mute keyword. And if you want to add data, you use dot push, and then you just add whatever the element is. Push always adds to the front, or sorry, the back. So this data would read 5, 6, 7, 8 in our vector v. If we want to get an element, we use the dot get function, which returns an option. So you'd have to unwrap your data if you use the dot get function. So generally, it makes your code more complicated and harder to read. So while there are use cases for using the get, and there are places where it's better, generally we recommend you just use square bracket notation. So you can see examples of this below. And yeah, that about does it. That's everything we have for this lecture. Reminder that the extra 0 credit practice problems are always open. They're good for getting your hands and sharpening your Rust abilities. Homework one's going to be released tonight, or sorry, tomorrow night, along with our supplementary lecture. But make sure you're on top of that. You're getting those done because those get very hard very quickly. And we will be having a Monday office hours in person. And of course, we always have our online office hours. So make sure to come to us if you need help. This entire lecture was in chapter 2 on the Rust textbook and the Rust documents. And chapter 8 is for vectors. And yeah, it was a great talking to you guys. I'm looking forward to seeing you guys next week.